section 3.1, complex numbers. Suppose you're working with real numbers and you need to solve the following equation: x squared plus 1 equals 0. Let's follow the steps, right, that we usually follow when we solve equations for real numbers, right? First step should be subtract 1 in both sides, right? So x squared should be equal to -1. Welcome, Anna. We just started. We are talking about complex numbers. Okay, great. So x squared equals -1. Next step should be, we should take square roots of both sides of this equation, right? Square root here, square root here, but that comes with a price. You have to write here a plus minus because this exponent is even, right? Plus minus square root of -1. All right, so finally we get x equal plus minus the square root of -1, right? And there we are kind of in trouble, right? Because we are working with real numbers and the square root of -1 for the system of real numbers does not make sense, it's undefined. Welcome, Halum. We just started talking about complex numbers. Okay, so this square root of -1, again, when working with real numbers, undefined. Mathematicians thought of it and figure out a new system of numbers called the complex numbers, where fortunately this makes sense. This makes sense, okay? And how they did it? Well, if you work with complex numbers, it is possible to compute the square roots of negative numbers so that we can find solutions when we deal with this type of equations, right? Mm-hmm. All right, it's you're gonna see this system of complex numbers as an upgrade of the system of real numbers, right? We will be able to do everything we're doing with real numbers, but it will come with a bonus. We will be able to do more things, such as taking square roots of negative numbers, right? That's the idea. Think of it as an upgrade of the system of real numbers. All right, so mathematicians started by defining this as the imaginary unit I. I is defined as square root of -1, so that I squared will be equal to -1. And this, which did not make sense for us when working with real numbers, now it will make sense when working with complex numbers, right? Yeah, that's the idea. All right, continue here. So let's just write this, right? When working with real numbers, this is undefined, right? This is undefined. Let's do it nicely here. This is undefined, but working with complex numbers, it makes sense. This is undefined. The ones who have joined, welcome all you guys. We're talking about complex numbers. We just said that for real numbers, this doesn't make sense, but for complex numbers, it does. When you define this imaginary unit, I as a square root of -1, right? Such that I squared -1. Try to recall this. Okay, so we can write the square root of any negative number as a multiple of I. How? This way. Suppose you encounter when you solve, let's say, quadratic equations, this number, square root of -25. Well, that can be seen as the square root of 25 multiplied by -1, okay? And that, once you distribute your square roots, can be seen as a square root of 25 is just 5. And this guy, square root of -1, we said We're gonna call it I, so phi I, right? Phi I. Follow, guys? So square root of negative number, multiples of I. Similarly here, if they ask you to figure out what should be a square root of negative 12, following the same idea, factor this as 12 times negative 1. A square root of 12, we can deal with that. A square root of negative 1 here after you distribute the square roots, right? Now, you got to recall from previous courses how you deal with this square root of 12. This square root of 12 has to be factored as a square number 4 times some other number, which is, in this case, 3, right? This I. All right, so a square root of 4, a square root of 3 times I, a square root of 4 is 2, a square root of 3 multiplied by I. And that's it, right? So whenever they ask you to simplify this type of expressions, this is what you should do. Now, the square roots of negative numbers are called imaginary numbers. So all these guys, imaginary numbers, right? So now mathematicians came up with this definition for a complex number, a formal definition. A complex number is the sum of a real number, and an imaginary number, imaginary number here, imaginary number, imaginary number. It's basically a two-dimensional number, right? Has two parts, a real part and an imaginary part. And that can be expressed in a standard form when you write it as A plus BI, where A, this part, we're gonna associate this with the blue color, where A is the real part, and BI, this part, BI, will be the imaginary part, okay? Plus BI, imaginary part. Imaginary part, okay? For example, if you see this complex number, 5 plus 2i, 5 plus 2i, 5 plus 2i, that number is a complex number because it has a real part, in this case, the number 5, right? Real part, let's write here, real part. And these 2i, imaginary parts, right? Include the sign here, so imaginary part, imaginary. Part, okay? Yeah. And together they form what is called a complex number, right? Complex number. So a complex number should have always two parts, right? It's a two-dimensional number, right? Two parts, real part, imaginary part, okay? Now, these complex numbers can be put in one-to-one correspondence with points in a plane, right? Because they're two-dimensional numbers, right? Come in pairs. So there is a simple way to plot these complex numbers into what is called the complex plane. Remember, with real numbers, we were able to put in one-to-one correspondence points of a line with real numbers, right? I said, since these complex numbers are an upgrade of the real numbers, you can do more. Now you can put in one-to-one correspondence the points of a plane, okay? How? It's very easy. I will show you. Suppose they say set 2 plus 4i minus 2 plus 3i, 1 minus 3i, 4 plus 0i, and 0 plus 3i on the complex plane. Well, quickly you identify your real part and your imaginary part, okay? Imaginary part and real part. 2 real part plus 4i imaginary part, right? Imaginary part here. So you start by going 2 units to the right because 2 is positive, right? 2 units to the right. 2 is positive, 1, 2, 2 units to the right. And then 4 units up, 4 units up, right? The real part, for the real part, you use the x-axis. For the imaginary part, you use the y-axis, right? That's the agreement. So then going up 4 units, right? Going up 4 units, 1, 2, 3, 4. You end up here, right? And this should be the point. This should be the point which mathematicians associate uniquely with this complex number 2 plus 4i, right? You follow, guys? Very good. Another example here, minus 2 plus 3i, minus 2 plus 3i. Quickly identify your real part, this case minus 2, and then your imaginary part, plus 3i, right? Plus 3i, plus 3i. And try to remember this, guys, for your homework. It's going to help you. I'm going to ask you to do this plotting. Negative 2 tells me that I have to do this. I have to go 2 units now to the left, right? So this negative 2, and then follow by 3 units up, 3 units up, because the complex number or the complex, the imaginary part, better said, is a positive 3. So up to 3, yeah. And that's it. This is your complex number, negative 2 plus 3i. Okay. Another one here, 1 minus 3i. Immediately identify your real part, followed by your imaginary part. 1 tells me that I have to go 1 up, but not to the right, right? Remember, the real part is measured on the x-axis, so 1 to the right, and 3 down, because this is negative 3i, right? 3 down, 1 to the right, 3 down. So 3 down means 1, 2, 3 out down here, right? 3 down. Yeah, very good, very good. And this, guys, should be our complex number 1 minus 3i. Now we reach this 4 plus 0i, 4 plus 0i. This complex number often, very often, I would say, will be identified as this, just the number 4, right? But be careful there, guys. If you are working with complex numbers and you see this number 4 just by itself, right? Often written as 4, right? You see a 4. It's not a real number 4. It's a complex number. It's the complex number 4 plus 0i, right? So 4 real part, which means that you have to move 4 units, 1, 2, 3, 4 units to the right, right? To the right, 4 units. And then 0i means that you do not move up or down, right? Neither up nor down, just stay there, because 0 is the imaginary part, right? So this will be the number 4 plus 0i, which mathematicians very often write just as 4, right? But it's 4 plus 0i, it's a complex number. All right. And similarly here, the complex number 0 plus 3i, 0 real part plus 3i imaginary part is often written as this. I will show you now. Often written as this. Often written as just 3i, right? 3i. But it's in reality 0 plus 3i, complex number. So real part 0 means you do not move along the x-axis, right? You stay here at the origin, right? Because 0 is the real part. And 3i tells you just go up 3 units, right? 1, 2, 3. So 1, 2, 3 here. Up. And there you will have this complex number, which is 3i, right? 3i. This type of complex numbers, the mathematicians call them purely imaginary, purely real, right? Understood why. All right, but now I'm gonna ask you to do something backwards, which is what actually you have to do in your homework. What if I give you a point, for example, here, this point, let's pick a nice point here, this point. And I ask you guys to figure out for this point P, right? What are the coordinates, or what is the complex number associated to the point P? Anybody could write on the chat by looking at this method sort of backwards, right? If they say identify this point P on the complex plane, right, with a complex number, what would that be? Could you think of that? Write it in the chat or say. Remember the distance on the x-axis associated with the real part, the distance on the y-axis associated with the imaginary part. Jay, excellent, excellent. 4 minus 2i. Excellent, 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 right? Yeah, because look, in order to get to this point, I have to go 1, 2, 3, 1, 2, 3, 4 units to the right. That will define the real part. And then after that, I have to go down here 2 units, right? Down, 2 units down. So minus 2, right? Minus 2i. Excellent, excellent, right? Try to remember this, guys, so that you will be okay on your homework. They will give you a bunch of points and you will have to do this, right? And identify what is the complex number that identifies that point uniquely, right? Very good, very good. Yeah, great. All right, guys, time to practice before we go over the operation with complex numbers. So let's go to the worksheet. It's down here. And I want you to work on these problems. So the first one, can you do this? Yeah, and the square root of -9, right? It's an imaginary number. And now that we have these complex numbers, we can express these imaginary numbers, right? So square root of negative number. So try to do that, please. Number 1. Let us know in the chat. Very good. I see. Someone figured this out. Gabriela, very good. Very good, Gabriela. Excellent, excellent. Gabriela, remember, just factor square root of -9, factor -9 as 9 positive multiplied by -1, right? That's the idea. And once you do that, you can distribute your square roots. The square root of 9 is just 3. And this guy we said is just I, right? I. So answer 3i. Excellent, excellent. What about number 3? Can you try number 3? What should be the square root of -50 using complex numbers? Try to figure this out. You may have to do some simplifications there, right? Try to remember how to simplify radicals who are not exact, right? Which are not exact. And the hint, again, I can give you the hint. Factor this as this, right? I can see on the chat. Gabriela, excellent, excellent. Very good, very good. Yeah, once you factor -50, that's 50 times -1. This allows you to distribute the radicals. But this guy, the square root of 50, is a square root of 25 times 2, right? You learned to do this in previous courses. And the square root of -1, we said is just I. Now, if you distribute the square roots here, square root of 2, the square root of 25 is 5. The square root of 2 is not exact, so leave it alone. 5 square root of 2 times I, right? Very good, very good. And this is this. Yeah, excellent, excellent. Very good, guys. This number 2, you can do it at home. Okay. And now let's talk about arithmetic operations with these complex numbers, right? Addition, subtraction, multiplication, and division. So let's go back to a lecture and let me show you how you should add or subtract accordingly, right? Complex numbers. Turns out addition and subtraction of complex numbers is component wise. We do it by combining the real parts and combining the imaginary parts. For example, if they ask you to, in general, to add two complex numbers such as a plus bi plus c plus di, the result should be a plus c plus b plus d times I. The sum of the real parts here, the sum of the real imaginary parts here, right? Attached to the imaginary part I, right? Similarly, for subtraction, you do it component wise. Subtract the real parts, that will be the real part, and then subtract the imaginary parts, attach I, that will be imaginary part, right? Now, however, when adding or subtracting complex numbers, there is a nice alternative. I'm going to write it here, alternative. Alternative, do it by combining like terms, by combining like terms. This is a powerful idea. Basically, you treat the complex numbers as binomials, right? And you know, combine like terms accordingly, and you should get the result, okay? Instead of following formulas, because for multiplication and division, the formulas will get a little bit complicated to remember. So alternative, do it somehow by combining like terms. How does that work, Professor, combining like terms? Well, you, for example, if they ask you to add these two complex numbers, you simply look at them as if they were binomials, right? Binomials. So if these guys were binomials, you simply remove the parentheses, right? So you get 5 minus 2i plus, here remove parentheses, 7 plus 6i, right? And combine like terms. These two like terms, 5 plus 7 is just a 12, right? Another pair of like terms, minus 2i plus 6i, minus 2 plus 6, 4i, right? That's it. So as you can see, I didn't use formulas, just combine like terms, and I got my answer here, right? 12 plus 4i. Very good. Example 2. Suppose instead of adding, they ask you to subtract two complex numbers. What to do? Similarly, right? Think of subtracting two binomials, right? Binomials. So for the first complex number, remove parentheses, right? You get this. For the second, also remove parentheses, but remember this negative sign together with this invisible one means that you have to multiply this by -1, right? This is going to be plus 20, -1 times I minus I, right? And then again, combine like terms. This and this together, 14 plus 20, 34, right? This and this like terms, invisible one there, 4 minus 1 is just 3, right? 3, invisible one, 3i, 3i, right? 3i. And that's it, that's it. So as you can see, guys, combining like terms is a good idea. So we quickly deal with this, right? Now, I want you to practice on this first before going over multiplication, division. So can you try number, start with something easy here. 5. Can you try number 5? It's asking you to do this 9 plus 5i minus 8 plus I, right? And the hint is combine like terms. Hint, combine like terms, right? I'm writing this between quotations because uh, they are like binomials, right? They're not binomials, but they can be treated as binomials for the purpose of getting the difference of these two complex numbers. Hmm? Yeah, distribute the negative sign over, multiplying, and then combine like terms. Ah, very good, very good. I see some activity in the chat room. Mohina, very good, excellent. Excellent, you figured this out. Also, Jay, very good, Jay. Very good, excellent, excellent, guys. So basically, we look at these two complex numbers as if they were just binomials, right? 9 plus 5i. This minus times minus plus 8 minus times I minus I, right? And then just combine like terms. 9 plus 8 is 17, right? 5i minus I, 4i. And then we're done, right? We're done. This guy. This was sort of subtraction. Let me ask you now to do addition. So can you do this? I will write it here, 8i plus 9 minus 7 minus I. Can you figure this out? This is a complex number, but it's purely imaginary, right? The real part is 0. The real part, so don't worry about the real part is 0. So just combine like terms, or you can use the formulas too if you want to. Now figure out what should be the sum of those two complex numbers. Yeah, and again, I see in the chat. Jay, let's see. Jay, very good. Excellent, excellent. Yeah, good work there. So you figure it out, right? Remember, it's all about simplifying, right? Combining like terms, basically. So this is what we're gonna do. AI, this is positive. So I just remove the parentheses, right? Minus 7 minus I. Or sometimes students think of multiplying by +1, but plus times minus minus, plus times minus minus, same thing, right? And then finally, AI minus I combined, after I write just minus 7 as the real part, is A minus 1, 7, right? 7i. Notice how always the real part should come up front and the imaginary part next to it, right? At the end. So minus 7 plus 7i. Yeah, very good, very good. Where is this guy? Excellent. All right, guys. Now, combining both addition, subtraction. Sometimes they're gonna give you this kind of thing. I wanna warn you, right? And this is where really the approach of simplifying really pays off, because here sometimes they may ask you to do this with not 2 but 3, 4 complex numbers, right? A combination of operations there. Can you handle this? Can you do this? Simplify and get the result, right? 3 complex numbers there together, subtractions. Yeah, figure this out, please. And if you have questions, guys, as usual, just let me know verbally or you can write in the chat your questions. Aha. I see some activity in the chat room. Aha. Two students have posted. Yeah, very good, guys. Aha. Gabriela and Jay. Excellent, excellent. Very good, excellent. Yeah, basically, we just simplify this, right? -2 here, minus times -2 plus 2, minus times -8 plus 8i, don't forget the I, minus times minus plus 2, minus times minus plus 6i, right? And then just combine like terms. Look, -2 plus 2, 0. There is just a 2 there that stays plus the sum of these two imaginary parts, 8i plus 6i, 14i, right? 14i. So which tell us that the answer should be this guy. Excellent, excellent. All right, guys. So I think we have mastered adding and subtracting complex numbers, right? These ones you should do them at home. Let's talk about multiplication and division of complex numbers, which is a little bit different than adding and subtracting because it's not component wise. It's not. I will explain. So let's talk about that, right? So let's continue with the lecture here. Let's talk about multiplying complex numbers first. It turns out when you multiply two complex numbers and follow the fact that I squared is -1, if you FOIL this out, this is what you get. This is what you get. Mathematicians has done it. They present the result as this formula. A plus bi times c plus di equal a times c minus bd, the real part, plus a times d plus b times c, all within parentheses times I, the imaginary part, right? But however, this formula is very difficult to remember, right? Very difficult to remember. So equivalently, again, you should follow this. Equivalently, we can multiply complex numbers in the same way we multiply binomials, FOIL method, right? How? Well, let me show you an example. Suppose they ask you to multiply 4 plus 3i times 2 minus 5i. How we do that? Well, think of multiplying two binomials using the FOIL method, right? Using the FOIL method. So you start this, you multiply 4 times 2, right? This times this. That is an 8. Then you continue 4 times -5i should be -20i, right? -20i. Now multiply this guy. 3i times 2. 3i times 2 plus 6i, right? And 3i times -5i. Be careful here. 3 times -5, -15. I times I squared, right? I squared. Follow, guys? I squared. Now, this is going to be 8. If you combine these two like terms, that's going to be just -20 plus 6 minus 14i, right? Minus 14i. And here, I want you to be careful. I squared. What is I squared? Anybody could tell us in the chat, what is this guy? Recall a square root of -I, the -1, sorry, is I, right? So then I squared is yeah, so yeah, it's something that you have to remember to do this. Very good, Gabriela. -1, right? Very good, excellent. I squared -1. Try to recall this, guys. So whenever you see I squared, you should substitute that with -1. All right, so we continue our work. A minus 14i minus 15 times -1 is just plus 15, right? 8 plus 15, 8 plus 15 is going to be just a 23, 23. minus 14i, right? Final answer. As you can see, I didn't use the formulas because they're complicated, but instead I just FOIL this out and recall this fact, I squared -1, right? And then I was able to get the answer. If you want to follow the formulas, also you can follow the formula, you will get the same result, right? That's what I just wanted to point out. All right, so now this is the first example. Example 2, sometimes multiplication of complex numbers will be given to you in this form. Compute the square of a complex number, 5 minus 3i squared. So how we do that? Well, remember the square of 5 plus minus 3i is just 5 minus 3i multiplied by itself, right? Multiply by itself. This is how you deal with the square of binomials, right? Remember? And then FOIL this out, right? FOIL this out. 5 times 5 is 25. 5 times -3i, -15i. Now, -3i times 5, -15i. Here, be careful. -3i times -3i. Negative and negative, positive. 3 times 3, 9, right? Positive 9. Then I times I square, right? I square. Now, combining like terms here, we get minus 30i, right? And this guy, I square, we know is just -1, right? -1. So this right here, 9 times -1. Continue doing the math, 25 minus 30i, minus 9, right? Minus 9. 9 positive times -1, 9 minus 9. And basically, 25 minus 9, just 16, right? Minus 30i. Very good. And that should be the answer, right? Follow, guys? It's just like multiplying binomials. Very good. So I want you to practice now on multiplication of complex numbers. So I'm going to ask you to do some exercises here on the worksheet. Can you try, I think number 13 is, will fit it for this part, 13, this one. Can you try this one? There are a lot of negative signs. Be careful with the signs there. 8 minus 6i times minus 5 minus 3i. Hint, FOIL this out, right? FOIL this out. So this times this times this, right? And then I square, remember, must be substituted by -1. So go ahead and try, guys. If you need to use a calculator for some computations, to simplify, feel free to use it. Sometimes the number might not be that friendly, right? Yeah, hint here, FOIL out. FOIL it out. And recall that I square is -1, right? Together with that, you should be able to get your answer. FOIL it out. I see some activity in the chat room. Mohina, yeah, you made my day. Excellent, excellent. 58 negative plus 6i. Excellent. Very good, very good. Yeah, so let's work this out, right? 8 times -5 minus 40. 8 times -3 minus 24i. -6i times -5 is positive 30i. negative 6i times negative 3i, positive 18i squared. Combining like terms here, minus 40 minus or plus, in this case, right? The dominant is 30, so plus 6. And this guy, remember, this I squared, not a problem for us because it's just negative 1. So plus 18 times negative 1. Mm-hmm. Yeah, and then when you do the math, guys, here you will see that this just becomes negative 18 together with the negative 40 that you see there is going to give you, yes, negative 58, right? Negative 58 plus 6i. Yeah, excellent, excellent. This guy, right? Very good. Sorry, marking in the here. Excellent. Now, can you try this, guys? 4 plus 9i squared. And the hint should be this, right? 4 plus 9i squared is 4 plus 9i times 4 plus 9i, right? FOIL this out, right? Sometimes the students ask me, Professor, what if I distribute the exponent over? There is no rule that says that you can distribute the exponent over a sum, right? So don't do that. Instead, this is what you have to do, right? Yeah, try that. Just FOIL this out. Mm-hmm. Mm-hmm. All right, guys, let's do it together, okay? I see. I see. Number 14. Gabriela, excellent, excellent. Yeah, you made my day. Mohina also, very good, guys. Yeah, I see. We are doing well here. 4 times 4, 16, right? 4 times 9, 36i. Again here, 36i. This 81i squared, right? 81i squared. But I squared, remember, is just negative 1. Combining these two like terms, I get 72i. This will be, since this is negative 1, multiplied by 81, negative 81. And when you do the math here, you may use your calculator, your Desmos scientific calculator, or any scientific calculator of your choice. 16 minus 81 is negative 65 plus 72i should be the final answer. Okay. Very good, guys. Very good, guys. So this one, right? Very good. Now let me show you how to divide complex numbers. Okay, how to divide complex numbers, so we can go over one of those exercises. Going back to our notes, here dividing complex numbers. Again, turns out dividing complex numbers is not component wise, right? Unfortunately, it's a different system compared to real numbers, right? Mathematicians figure out, however, what the formula is this: c plus di divided by a plus bi, c times a plus bd over a squared plus b squared plus ad minus cb over a squared plus b squared times I. Very complicated formula, right? Not easy to remember. However, there is an alternative to kind of go around the formula and do it differently but equivalently. We can divide complex numbers by multiplying the denominator and the numerator by the complex conjugate of the denominator. Professor, what is complex conjugate? Well, let me explain to you what that is. The complex conjugate of a plus bi is going to be a minus bi. Basically, you keep the real part as it is, and for the imaginary part, you just change the sign. You just change the sign, right, to its opposite. To its opposite. It is found by changing the sign of the imaginary parts, right? Very good. So examples. Complex number 6 plus 4i. Complex conjugate should be 6 stays the same, the real part, the imaginary part changes sign, minus 4i, right? On the chat, if the complex number is 3 minus 7i, what should be the complex conjugate? Anybody for this? 3 minus 7i. Remember, keep the real part unchanged and just change the sign of the imaginary part, right? So for this guy, what should we write here? Hey, all right, let's see together, right? The real part stays the same, 3. Imaginary part change to its opposite, plus 7i, right? Plus 7i. For the third one, what should be the complex conjugate? Anybody for this one? Remember, keep the real part as it is and change the imaginary part. I see. So students here, hosting. Excellent, Mujina. Excellent, right? And the next two, very good. Excellent. So for this, keeping this and change the real part, we change the sign of the imaginary part plus 2i. That's the complex conjugate of this complex number. And for this number, you may say, Professor, where is the real part? Remember, when you don't see a real part, the real part is 0, right? This is like 0 plus 3i, right? This is 3i. Yeah, this is it. So the complex conjugate of this should be just 0, which we don't write, just minus 3i, right? Very good. Excellent, guys. So now we are ready for division of complex number using multiplication by the complex conjugate. Suppose they give you this division of complex number 2 plus 5i divided by 4 minus I. How you do this? Well, quickly we look at the denominator and identify its complex conjugate, right? Its complex conjugate. So the complex conjugate of the denominator is going to be 4 plus I, right? And that is what we're going to use to multiply numerator and denominator by. So we're going to multiply the denominator by 4 plus I and the numerator by 4 plus I to keep this fraction balanced, right? Or unchanged. Okay, so doing that, on the numerator, I'm going to have 2 times 4, 8, 2 times I, 2i, 5i times 4, 20i, 5i times I, plus 5i squared, right? 5i squared. On the denominator, something special is going to happen. 4 times 4, 16. 4 times I, 4i. Minus I times 4, minus 4i. Minus I times I, minus I squared, right? You said something special will happen, Professor. What is that? This. The second term and the third term will always cancel each other out. This is a property of multiplying a complex number times its conjugate. The imaginary part disappears. You will see. Okay, so if you continue working here, this guy's 22i, right? This is going to be a -1, right? -1 there, multiplying 5 minus 5 plus 8, which is going to be just 3, plus 22i, right? The sum of these two. Right, that goes on the numerator. On the denominator, notice this is -1, right? -1. But -1 multiplied by -1 is +1. Added to this 16, 17, right? This is it. Now, mathematicians like to see clearly what is the real part, what is the imaginary part. For that purpose, they divide whatever you get here on the denominator must be divided into the two parts of the numerator. So 17 into 3 is 3 over 17 plus 17 into 22, 22 over 17i, right? And this is how you should present your complex number, your answer, right? Showing clearly what's the real part, what's the imaginary part. Good. So as you can see, I didn't use the formulas, right? I just multiply by the conjugate, right? But however, if you use the formula, you follow these formulas, you can still get the same answer, right? It's equivalent. You choose what you do, right? All right, great. Mojina, yeah. Yeah, the idea, Mojina, let's repeat, right? When you divide two complex numbers, identify, quickly look at the denominator, always the denominator. This is the denominator, right? Now you're gonna find the complex conjugate of the denominator, which is this 4 plus I, right? And you multiply by 4 plus I the denominator and the numerator, because the idea is we don't want to change the value of this fraction, right? So if you multiply the denominator, you must multiply the numerator as well. Then you multiply these two complex numbers as we did before, right? Foiling out, replacing I squared by -1 here also. But also here on the denominator, you will notice that the second term and the third term will always cancel. This is what happens when you multiply a complex number by its conjugate. And then you do the math, you simplify, get this. And from here, we dividing 17 into 3 into 22, you get this, right? Mojina, yeah, now it's better. Yeah, and if not, something is not clear, guys, always let me know. I can repeat, okay? Okay, but now it's important that you do this yourself. So let me give you an example here on the worksheet. Very good, very good, very good. In the worksheet, let's see. There is one that is will fit it here. Number 18, yeah, I see it here. Can you try this guy? You may have to simplify in the end if you get some fractions there that allow you to simplify, okay? So try to do this. I will write it here, bigger. 5 minus 4i over 8 plus 6i, right? And the hint is going to be quickly see the denominator, identify it, and then multiply both numerator and denominator by the complex conjugate of the denominator, which is this, right? So this is what you gotta do. This will allow you to get the answer for this division of complex numbers. So go ahead and try. You may have to use the calculator for some partial computation there if needed, right? So have ready your calculator. Okay. So I think we should go over this together because I want to explain also how to solve. Yeah, we can then take a break and then explain how to solve quadratic equation using this complex number. Okay, so working here together, 5 times 8 will be just 40, right? 5 times -6i minus 30i. Then we have this times this minus 32i. And this times this positive 24i squared, right? I squared. All right, all over. 8 times 8, 64. 8 times -6, negative 48i, right? 6i times 8, positive 48i. 6i times negative 6i minus 36i squared, right? I squared. Now, on the numerator, what we're going to have? 40, right? Here, this together, negative 62i, right? Negative 62i. This is negative 1, right? This I squared. Remember, I squared negative 1. So 40 minus 24, 40 minus 24 is going to be just 16, right? 16. You can get it with the calculator, right? This 2 minus 62i, done with the numerator, right? Done with the numerator. Now, for the denominator, remember, always these two guys, the second term, the third term will cancel each other out. And you will be left with 64 minus 36 multiplied by I squared. But this I squared is negative 1, right? Negative 1 times negative 36, positive 36. Positive 36 plus 64 is 100, right? 100. Yeah, 100 here. Now, finally, look. Remember, we explained that mathematicians want to see clearly what is the real part, what is the imaginary part. So for that purpose, this division by 100 into 16 into 62 is required. But now notice 16 and 100, they have greatest common factor device, or greatest common factor 4. So we can simplify this, divided by 4 numerator and denominator. This will be 4 over 25 in simplified form, minus here 62 and 100 even numbers. So let's divide them by 2. 31 over 50, right? I. Follow, guys? And this is shown on choice D. You follow? Sometimes you may have to simplify, right? Try to recall this for your homework and for your examination, exam 2 that is coming at the beginning of November, at the end of October, right? All right, so this is it. Very good. So now I think it's a good time to take a break. So let's take a break. And after the break, we will come back and talk about how to solve quadratic equations using complex numbers. And also we'll talk about quadratic functions in general, okay? In general, so break time. Let's go from 12:58 to 1:08. All right. Okay, guys, feel free to rest, take a break, or a cup of coffee, tea, water. Or if you have questions about a web work, which is still open, I kept it open till today at 11:59. Feel free to bring up questions related to the homework problems, or also if you have any issues with special assignment 1, also I am still receiving a submission, so do it, submit it in black, right? If you cannot print it out, you need to print it out. At the MCC, you can print it out. There are computers there in the labs, right? Or when we meet in person on Wednesday, you can print it out in our classroom. I think it's possible to print out stuff there. So any questions from the homework section, or any comments? Just let me know, okay? Otherwise, we can just rest. New homework has appeared in your account, right? So you may also take a look at it now and see if you have any issues with those. This homework is related to complex numbers and related to what we're gonna do next, the quadratic functions, right? Quadratic functions. A question here. Sure, Mujina. You can ask me about let me pull out the special assignment one and see what question you have. Okay, let me pull out that special assignment one. So let me see. Special assignment one. Okay. Okay, Mojina, I have the special assignment one here. Which question you need help with there? You write on the chat or say? Very good, very good. Number 3. Let's comment on number 3, okay? Number 2, number 3. You can purchase a motorcycle for $7,101 or lease it for a down payment of $783 and $243 per month. Find an equation that describes how the cost of the lease depends on time. How long can you lease the motorcycle before you have paid more than its purchase price? All right, they're asking you, Mohina, to figure out an equation for the lease cost, right? Lease cost. All right, so let's do this. Let me give you an idea of what should be done here, right? Lease cost. Let's represent this function as Lx. This lease cost has two components, right? Fixed cost, remember? Cost plus variable cost, right? Two components. Mojina, what do you think should be the fixed cost there by looking at this problem? Yeah, let's see. No, but that yeah. Halo is suggesting, right? Yeah, very good. The idea, Mojina, is here that when you talk about the lease, try to focus on this part, right? Yeah, in this part. Look, try to focus on this part because this is what the cost of the vehicle is, right? The cost, but the lease deals with this part. They're saying for a lease, down payment should be this, right? The down payment means what you pay no matter what, right? The very beginning of the lease. And these are monthly payments, right? So clearly, this should be the fixed cost, right? The fixed cost. Yeah, very good. 83. Now, Mujina, variable cost. What do you think should be the variable cost? Noticing this. And letting X be the number of months that you will go over the lease, right? Let X be count the number of months. Very good. Excellent, right? Yeah, excellent. Yeah, so if you let, and you have to write it, right, in the assignment, right? Let X be the number of months for the lease, right? You have to state it somewhere. They know how to see that this 243, since it's what you will pay each month, right? 243 must be multiplied by X, right? You follow that now, Mujina? That's the least function, right? Yeah. Yeah, and then you have to use this function to figure out, right, the answer to the question, which is this function is going to grow month by month, right? Month by month will grow, but there is going to be a point when it's going to reach this amount, right? This is what I'm asking you to find, right? How long, how many months it would take for this least function to achieve this amount, right? And for that, the hint is let this be the cause of the least, right? And set this equal to that and solve for x, right? You follow the hint, Mohina? Now you are okay with this question? Okay, great, excellent. Yeah, very good, very good. Yeah, guys, whenever you need hints or uh, whenever you need help, just let me know. I'm happy to help. Yeah, it's not complicated question, but it's a little bit tricky probably because not everyone is familiar with the leasing system, right? I guess. But leasing is just basically like a rental, right? You are renting the car for some period of time. Yeah, you're welcome. I'm happy to help. Mhm. Yeah, no, it's okay. It's okay. Yeah. Yeah, very good. Very good. Now it's good. Now it's good. That's what matters. All right, let me clear this up. Any other question, guys? Remember the special assignments. I'm still receiving special assignments. A few students couldn't finish because of printing issues. Go this week to BMCC and or on Wednesday, right, when we meet in person. I can show you how you can print out from your computer, right, from your station. You can send out and print it out there, or in the, I think it's in the first floor basement of Federman. They have a computer lab, so you just show your ID, BMCC ID, and they will allow you to print whatever you need to print. Okay. Yeah, very good. Or if you can, if you have a way to write as I do, right, with a electronic pen on the assignment, that's also acceptable. Okay. Any way you can present the assignment, submit it as a PDF, right? Is acceptable. Okay, guys, I think we should go back to the to our lecture. So let's close this and let's talk about how these complex numbers can help us to solve any quadratic equation whatsoever. This type of quadratic equations, this type of quadratic equations, right? You can see that the answers are complex numbers, right? So let me explain that to you. Let's go back to the lecture. Yeah, we did this, we did this. So dividing also, there are a lot of exercises that you can do at home there in the worksheet, right? Do that. All right, so let's go. Okay, now let's go to using complex numbers to solve quadratic equations using complex numbers. All right, so basically, you know, right, that when you are given a quadratic equation that looks like this, a times x squared plus bx plus c equals 0, where a, b, and c are real numbers, right? Then the solution of that equation is given by this so-called quadratic formula, right? Quadratic formula. Yeah, this is what is mathematicians call quadratic formula. Quadratic formula. All right, so, but now the quadratic formula has this component, this is square root, right? And sometimes you may get for the inside of the square root, which is called the radicand, a negative real number. So in that case, now that we are using complex numbers, use your knowledge to deal with the square root of negative numbers via complex numbers, right? So example here, suppose they ask you to solve this quadratic equation, x squared plus 2x plus 5 equals 0. Well, quickly, you notice that a is this invisible one, right? B is 2, and C is 5, right? Quickly identify A, B, and C. Now, if you use the quadratic formula here, which is something that you should either memorize or had it written, you're going to use this a lot. That will be minus B, but B is 2, right? Plus minus the square root of B squared, 2 squared minus 4AC. 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 Try to use parentheses, especially if you are substituting negative numbers, it will help you. B squared minus 4 times AC. A is 1, C is 5, right? Very good. Over twice A, right? Over twice A, twice 1. Let's work this out. x equal -2 plus minus what? Square root of 2 squared is 4. Negative 4 times 5, 20. 4 minus 20, negative 16, right? Negative 16. And you can compute these things with your calculator in case the numbers are not friendly. But now 2 times 1 is 2. Aha, Professor, I got myself in trouble. I got the inside of the radical as a negative number. Well, fortunately, we have now the knowledge of complex numbers. We can deal with this type of expressions, right? So x will be equal to what? -2 plus minus. Who can tell us what is this guy as a complex number? This guy as a complex number. Over 2 here. Aha, I see someone. Gabriela, yeah, you made my day. 4i, right? 4i. Remember, this guy, you separate 16 from -1. The square root of -1 is I. The square root of 16, 4, right? That's 4i. 4i. Very good. Excellent, excellent. So we, for this square root of -16, we write 4i. And that's pretty much it, because then after that, all you gotta do is you divide 2 into both, right? So this way, this is 4i. So circle this here. And then just do this. 2 into -2, 2 into 2i, and the answer should come out, right? Should come out there. X equal -1 plus and minus 2i, right? Now, guys, for the purpose of presentation, this is telling us that x could be -1 plus 2i. That's one solution, right? Or x could be -1 minus 2i, right? Another solution. This mathematicians put together in what they call a solution set, which is very common. You should be aware of this, especially when you post your answer on your homework. You may see your two answers written separated by commas this way with embraces, right? Why? Follow, guys? Positive here. Minus here, sorry, I wrote the positive already, the negative already. So the positive is here, the negative here, right? Yeah, this. Keep this way. Yeah, very good. These two solutions in solution set. That's it. Try to remember this for your homework, guys. It will help you out, okay?